Here we're looking at proving identities which involve Cosec and Cot, and eventually also Secx as well in example B. And we've talked about using the triple equals, and when we're trying to prove an identity, what we need to do is nothing crosses over the triple equals. We actually just work on either one side or the other side and then get it to look the same as its opposite side. So here, I'm going to work on the left-hand side of this one and try and manipulate it so that we can show that it's actually the same as the right-hand side here. So if I take cosec x minus sin x, then what I'm going to do is I'm going to try and write the cosec x in terms of sin x, and usually the best thing to do is take our either Cotx, sec x or cosec x, and when doing these sorts of proofs, try and write them in terms of sine, cosine and tangent. And usually, in fact, tangent is better written in terms of sine and cos. So we've got here Cotx, if you remember, is 1 over tan x, and actually that's would mean it's cos x over sin x. Sec x we've got is 1 over cos x, and cosec x is 1 over sin x. So if I write the cosec x as 1 over sin x here, 1 over sin x minus sin x, then what I'm going to try and do now is add them both together. And so we need to get a common denominator. And if we realize we can write sin x as sin x over 1, then I need to multiply the sin x over 1 top and bottom by sin x, so I've got the same common denominator as I have here. So then I'm going to get the 1 over sin x, which I already had, and then I'm going to get, if I multiply top and bottom of this fraction by sin x, I'll get sin squared x over sin x. I can now add them together because I've got a common denominator, so I'm going to get 1 minus sin squared x over sin x. And I'm now going to use another identity which we've come across before, and that is that sin squared x plus cos squared x is actually equal to 1. So if I rearrange this, I can say, well, if I take away sin squared x from both sides, then I'll end up with that cos squared x is equal to 1 minus sin squared x. So if I replace the top line, the numerator of this fraction, then what I'm going to get is that's equal to cos squared x over sin x. If I then write the cos squared x as cos squared times cos squared, I've got cos x times cos x over sin x, and in fact the cos x and the sin x is Cotx, as we've defined it up there. So it actually becomes Cotx cos x, which this was the left hand side of the equation, and so that equals the right hand side, and we've done it. That's what we was asked to do. We was asked to show that this left hand side was actually equal to the right hand side. So now we're going to look at B. So we've got tan x and then in brackets sec x minus tan x, and we're trying to show that it's equal to sin x over 1 plus sin x. So again, we're going to just work on the left-hand side of this and try and turn it into the right-hand side. So I've got the left-hand side is equal to, and if I write the tan x in terms of sine and cos, then it's going to be sine x over cos x, and then the sec x in the brackets is 1 over cos x, and tan x is going to be sine x over cos x. So if we then first of all turn our attention to the brackets there, I'm going to just add the fractions together. So we're going to have sine x and then cos x outside the bracket, and then that's going to be 1 minus sine x on the top of the bracket all over cos x. If I then multiply the denominators there, I'm going to get sine x and then 1 minus sine x instead in the bracket, but multiplying the denominators, I'm going to get cos squared x. If I then use the identity that we've used previously, which is cos squared x is equal to 1 minus sine squared x, then I can say that that's going to be sine, and then in brackets, as we had before, sine x, 1 minus sine squared x. And now, so it's quite a tricky one, this, but what we can do is use the difference of two squares identity here. So difference of two squares is that if we've got a squared minus b squared, then we can write that as a bracket of a plus b multiplied by a minus b. Well, in our case here, we've got our a is the 1 and our b is sine x. So what we'll end up with is sine x, I missed out the x on there, there we go, sine x and then 1 minus sine x still on the top, and then the bottom is going to be two brackets, it's going to be 1 plus sine x and 1 minus sine x. And now what we can see is we've got a repeater bracket on the top and bottom of the fraction. So the 1 minus sine x on the top and the 1 minus sine x on the bottom will disappear. And so that will just leave us with the sine x over 1 plus sine x, which is what we were required to find, sine x over 1 plus sine x. So that's equal to the right-hand side, and we've done it, we've shown it. So again, the principle here is to try and write everything just in terms of sine and cos, and then we can use a couple of identities to show that the left-hand side is equal to the right-hand side.